getting the Google Assistant SDK samples running on a Raspberry Pi 2. Today, in Mikey's lab. Welcome back to the lab. If this is your first visit with us, go ahead and click the subscribe button down below to ensure that you get the latest information on science, engineering, DIY, and maker life from the lab all the time. Today in the lab, we're looking at getting the Google Assistant SDK running on a Raspberry Pi 2. So lab code up. We're going to learn something today. Alright, so we've transitioned over to the bench here. What you have in front of us here is going to be our experimental setup. I say experimental because Google has been very pointed as to say that the Assistant runs on the Raspberry Pi 3. I can find no reason why the Assistant SDK shouldn't run on a Raspberry Pi 2. The processors are very similar. Everything should still be in line, and we're going to find out today if I'm correct about that. So in our experimental setup that you see here, we have a Raspberry Pi 2. This is an external sound card. I'm just using this particular USB sound card for this particular experimentation. If this works, or if when I go to use the Google SDK and other applications, I will probably choose a smaller USB sound card and probably direct solder the sound card to the Raspberry Pi. We have a small mic that's plugged into there. The audio output from this USB sound card is going to my TV, so you should definitely be able to hear it in the other in the background from the other mics. And we have a small little 7-inch LCD here that we can use to capture the output that I can't do via terminal, which I will obviously capture just with a screenshot. So let's go ahead and get started. If you have not already, check out the video on installing Raspbian on the Raspberry Pi. That install is basically where we're going to take off from. Okay, so as I said, we're starting from the point of the Raspbian install being finished. We used the images from the Raspberry Pi org in order to install Raspbian, and I'm just going to go ahead and power up the Raspberry Pi now. And as you can see on the screen, the Raspberry Pi is booting the Raspbian OS right now. If you see a little yellow lightning bolt here, that generally means that you were using a power supply that does not have enough amperage for what you're doing, and the Raspberry Pi is being undervolted. With these Raspberry Pis, I do generally recommend that you use a 2 amp power supply. I'm using an old Apple charger, which is 2 amps as well. Okay, so now that we're at the login screen for the Raspberry Pi, I've gone ahead and plugged a keyboard into the Raspberry Pi itself, and we're just going to log into the terminal with the Pi account. Okay, so one of the things that's very important, and it was part of my initial video, so it's already done here, but I'll walk you through it, is we're going to set up remote access to this Pi. The projects that we put it in probably will not have a display for us to see this command prompt, and it's much easier just to work from the PC itself. So we're going to do a sudo, which basically tells us that what we're asking the Pi to do, we're doing as a super user. Right, and I like to do -I, which sets the entire session to be the super user, so you don't have to type sudo for every command that you're using. And we're just going to go raspi config. Which brings up this menu. This has a whole bunch of options inside of it that you can play with. The one that we're interested in first off is number 5, and it's interfacing options, and we want SSH, which stands for Secured Shell, and will allow us to communicate with the Raspberry Pi from PuTTY from any other machine that's on the same network as the Raspberry Pi. The other option I like to do is under audio, I like to force HDMI audio. This will not apply with the USB sound card, but for a lot of other uses, if you're using this, for example, on a RetroPie setup, look for a video on that later. The Force HDMI will tell the Raspberry Pi that the only device that it can send audio out from is the HDMI port. Okay, so now that those are done, we're going to go ahead and we're just going to exit from this. And we're going to give it a quick reboot just to ensure that SSH is now enabled. Okay, so while that's rebooting, we're going to transition over to the actual desktop, and we'll do the majority of what's left for configuration through PuTTY on my Windows 7 box. Okay, so this is the screen you're going to see when you first launch PuTTY. We want to go ahead and make sure that SSH is selected, and we're going to type in for hostname 192.168.1.146, which is the address that we got off of the Raspberry Pi when we were verifying its IP address earlier. And we're going to go ahead and click Open, and that's going to create a window on the other monitor. So just drag that over here. And we're going to log in with the same credentials that we used before. And this will allow us to issue commands to the Raspberry Pi as if we had a keyboard directly plugged into it, which can be very, very handy. It's a lot more convenient for cutting and pasting when you're on this computer itself. Okay, so basically we've gotten the hardware set up as part of the tutorial that Google provides for using this. So we're going to go back to the next step, which is configure developer project and developer account settings. This is a very important step, and having gone through this before, this is probably the only place where you could possibly make a mistake. So the first thing we're going to do is we're going to just click the link on this page. There will be a link to these instructions down in the description below. Okay, so we can see that I set up the Raspberry Pi Assistant project here. If you don't have a project already created, you just go ahead and click Create Project. Name it whatever you're going to be working with. We'll create one called True, apparently, is the default, so we'll run with that. Alright, so now we're going to go back to the original tutorial that they told us to go through. Now that we have the project set up. Alright, so now we're back at this page. We've already created the project that we wanted to, that we'll be working with for this, so we're going to go ahead and click Enable the API. Okay, when you first get here and you first do this, there's going to be a button to click here that says Enable. Mine currently says Disable because because I've already done this before. So we're going to go ahead and I'm just going to click Disable to show you what that looks like. Okay, so this is the screen you're going to see when you get here and you've created a brand new project and you've never been here before. And literally all you have to do is click Enable. And you can see that no traffic has come back and forth through this particular page. So we're going to go back again and go to that documentation and proceed to the next step. This is kind of an interesting one that a lot of people could possibly get wrong. We have to create an OAuth ID. What that means is that is a file in a format called JSON. I may do a video later on explaining what JSON is, but it's just a text file containing a lot of information that you need to feed to the Raspberry Pi, and the Raspberry Pi uses this file in order to authenticate to the Google services. So we're going to go ahead and click Create No Auth Client ID, and this will load the Google API Manager. And for our needs, we're going to click on Other. I'm just going to leave it with the default Other Client 2, and we're going to go ahead and click on Create. So this is creating a session token for us to be able to connect to the Raspberry Pi. It gives us our client ID and it gives us our secret right here. For several clients that might be fine. There is a download link off of the main page here though that will give us the JSON file that will pass this information to Google directly and make it much, much easier for us. So we're just going to go ahead and click OK. And then when you find the OAuth client ID that you created, right, in our case, it's the Other Client 2 one that we just created. We're going to go ahead and click this little down arrow which says Download JSON. And your computer's going to ask you if you want to save it. Just click Save. Right, I'm going to go ahead and click Open Folder and grab that JSON file. Put it right at the root of my C drive. Why will become apparent in a couple minutes. Okay, so now we have virtually everything on the Google side set up and ready for our Raspberry Pi to be able to connect without an issue to Google, send the audio that it records for the requests that it has directly to Google without an issue. And we're going to go ahead and we're going to send that JSON to the Raspberry Pi at this point. Okay, so the way that Google suggests you do this is using a command line. I'm going to suggest you use a different tool that's very helpful for pretty much all things Raspberry Pi. And that is a program called Winscp. It is a free program. Just like Putty, I will put a link down in the description for you, so that you can get to this program without an issue. I'm going to go ahead right now. Okay, so when Winscp opens up, first thing it's going to ask you to do is come up with a new site. We don't necessarily have to save a site. I generally don't. As you can see, there's none saved here. The file transfer protocol we're going to use is SCP. The host name we're going to connect to is that IP address that we got from the Raspberry Pi earlier, which is 192.168.1.146. And the username and password are what we've been logging into the Pi with all along. So the username will be Pi, and the password will be whatever you changed it to during your Raspbian installation. Just like Putty, it's going to ask if we're sure we want to connect to this unknown server. Go ahead and say yes. And it gives us a directory listing right here. So if we go back to the instructions that were provided by Google, it tells us to put that JSON file in home/pi. Okay. So now we're going to go over to our transfer program. As you can see, the right-hand side is the directory structure for the Raspberry Pi. The left-hand side is your local directory structure. We are currently in the home/pi folder where we're supposed to put that JSON file. So I'm going to go on the left-hand side for this PC, go down to drive C, and I'm just going to go back up to the root of drive C, find that client secret JSON file that we got from Google, and send it over to the Raspberry Pi. Now what this has done is over the network copied that file to the Raspberry Pi's hard drive, and now it's in place. Okay, so now we're sliding back over to the Raspberry Pi to set up the audio properties, which is the next step in Google's instructions. For most people, these may not be 100%, but we're going to try first and see what we get. So the first instruction that they recommend that we do is a speaker test, which is a very simple speaker -test command. And we'll tell it to use the WAV file format for audio. Now obviously we don't hear anything, which means it's currently trying to use the wrong device for audio output. Alright, so it's definitely using the Broadcom ALSA mixer, which is the wrong mixer. So let's go tell it which one to use. So we're going to look at the recording devices first. We're going to go A-record -L and tell the Raspberry Pi to list all of its current recording available devices. And we see our USB audio device, which is device 0, card 1. That's very important for the next part. Okay, so I would write that down somewhere. Next, we're going to look at playback devices. Okay, for playback devices, we have the Broadcom device that's part of the Raspberry Pi, a secondary Broadcom device. The two of these, because one of them is the HDMI port and the other is the analog out port. And then we have the device USB one, which is card 1, device 0. Okay, so it's the same device for both input and output, and same card for both input and output. At this point, we need to set up a configuration file for ALSA so that it knows which devices to always use for recording and playback. This simply means that in the home of root.py where we are, we need to create a file called .asoundrc. Starting a file name with a period in Linux generally denotes that this is a system configuration file and will in most cases keep it hidden from your general users. If you've never used Nano before, there are a lot of tutorials around the internet, but just about everything you need to know is contained at the bottom of the screen here. The chevron icon tells you that you need to press Control and that button to activate that particular feature. So the first thing we want to do is define our playback and capture devices. For PCM, not default. For this, we're going to use type asym capture .pcm. Name is Mike. Playback.pcm. We're going to give the name speaker. And that ends that configuration block. So now it's going to look for two separate configuration blocks below it. Since we said that the capture settings for PCM are going to be under the mic section and the capture settings for playback PCM are going to be under the speaker section, we need to define what those are now. So what we're going to do is we're just going to define a PCM.mic. It is very important that the mic here matches exactly the mic above. This is case sensitive, and if you don't use the right case, then it's not going to find what we're looking for.
Front, left. Front, left. Front, left.
I'm just going to turn the audio up on the TV so that you have a chance of hearing
Front,
this.
left. Front, left. Front, left. Front, left.
Okay, we're going to go ahead and stop that because she's annoying. Okay, so the next test that they recommend that we do is a recording test. It will make sure that we can record audio from the mic device that we believe that we can, and that we can play that particular style of audio back. So what we're going to do for this particular test is we're going to use a simple arecord command. Okay, so what this probably means is that the mixer settings are not correct. So we're going to go into the ALSA mixer. Right, and I'm going to boost the audio level of the speakers right now. I'm going to try to go just before it thinks it's going to start clipping, which is when the color of the thing should be red. So I want to be at white. And then while I'm here, I'm going to go over and I'm going to go ahead and hit F4 to the capture device. It still is on the wrong device. F6 to select sound card. USB device. Okay. So I'm going to go ahead and raise the level again up to just before red for all of the channels. We're going to raise the volume for the speaker front, which is probably why we couldn't hear anything. turn the volume down on my TV because I'm pretty sure this is going to be kind of loud. We'll exit, which saves the changes, and we'll issue that play command again. Obviously, I still don't hear anything out of the audio, but chances are that's because it didn't record well. So we're going to go back and do the record again. This is another test with the balance levels and input levels of the audio set properly. Okay, so now after setting all of those sound parameters, we've rebooted the Pi to make sure that the audio subsystem can go ahead and pick up the changes that we made in those configuration files. I'm just going to do another speaker test just to be sure.
Front, left. Front,
Okay.
left.
So that
Front,
very annoying voice of that woman is definitely coming through, so we know we can play audio. Let's find out if we can record audio. So what we're going to do here is we're going to issue the recording command again. I'm going to grab this little lavalier mic one more time. And we're going to see if I can record audio now. This is a test of recording audio to the Raspberry Pi through this USB sound card, given the chance. Alright, so let's see if that worked. If we issue the play command for that particular file. This is a test of recording audio to the Raspberry Pi through this USB sound card. As I'm sure you heard that play through my TV, we now know that audio in both directions work fine. Okay, so what's left to do now is to set up the Pi for the actual SDK and get it properly linked into Google. So one of the very first things we should do, and you should technically always do this just as a note, is update the apt-get package in Raspbian and then upgrade all of the existing packages. We're gonna skip the upgrade simply because that usually takes a fair bit of time. But I am once again going to go into an interactive sudo prompt, which tells the Raspberry Pi that everything that I type from now on should be run as a super user. Otherwise, it can get quite annoying with the number of times you have to specifically specify. That makes no sense. Specifically specify? No. The number of times you need to specify that you want a command run as a super user. We're going to go apt-get. Apt is the package manager for this particular version of Linux. If people want to know more about it, leave comments down below and I'll be more than happy to tell you about that particular package. We're going to say update, which tells it to go out on the internet and update all of its known sources for software. This will take a couple of minutes, as you can see on the screen. It's going basically out to all of the repos that it knows and asking the repos what files are available from each of them. This will assist us when we try to install additional packages into this Linux distribution. One key example for this particular project at best is we're going to need to install Python 3. Okay, so that's gone ahead and updated. I'm going to tell it apt-get install Python 3-dev and Python 3-vn. Definitely helps if you spell Python correctly. Okay, so it's going to tell us it's going to take 73 more megs of disk space. So we're going to go ahead and click yes. What this is going to do is it's going to go out onto the internet. It's going to grab all of the packages it needs for the Python programming language, both the dev and the virtual environment side of Python. download it to the Raspberry Pi, and install it in its operating system. Obviously, depending on the speed of your computer, your internet connection, this can take a little bit of time. Okay, so we're back after a few minutes of downloading and installing those packages. Now it's time to go get the actual samples itself. Right, so we're again going to do an apt-get install port audio 19-dev lib ffi-dev and lib ssl-dev. These are prerequisites for, or dependencies for the sample itself. So we're just going to go ahead and install those. Very much like the last time, it's just fetching them from the internet and installing them onto the hard drive of the Raspberry Pi. Okay, so now we're going to go get, with the Python package manager, we're going to go get the actual source code. And we're back. So if, like me, the Google instructions kind of led you astray and missed a step, it's a good thing we're doing this way. And the PIP package was not installed, as you can see on the screenshot here. There is a way to get to it, and there is a way to do it, and I'm going to take you through it from the Raspberry Pi standpoint. Okay, so what we're going to do first off is we need a Python script that will install the PIP package. So we're going to go ahead and use the wget command, which causes your Raspberry Pi to download something from the web. Right, and we're going to download it from the address https://bootstrap.pypa.get-pip.py. Okay, and we can see that downloaded, and if we do an ls, it is there. And then all we have to do is issue the command Python and that particular script. And just like the apt-get system that we showed you earlier, this is going to go out onto the internet, grab all of the dependencies of the package, download everything, and install it on the hard drive of your Raspberry Pi. Okay, so now we're back to the command prompt. And now if we go ahead and tell it to install the Google SDK samples, Python is now going out and getting the samples from Google servers and downloading them to your particular Raspberry Pi. Once this is in place, we're going to bounce back to the PC and we're going to set up some actions on our Google account that we're going to use. Seem to be getting some interesting errors here that indicate to me that the python-dev package, which I requested installed from apt-get, has not installed. So we're going to go ahead and, we're back at the prompt anyway, and I'm going to do the apt-get python-dev. Again, just to see if it's properly installed. Alright, so now it wants to install more packages, so apparently the 2.7 as well. So there are some traps for new players in this. Definitely some traps for new players. Alright, so Python 3 was already set up. So now we're going to install those samples again, hopefully this time without the errors. Yeah, this time it seems to be going much, much better. Shocker, it takes a lot longer when it doesn't get errors. Okay, so after this command is finished, we're just going to jump right back to the PC. We're going to set up our Google account with the activity controls for this particular device, and then we're going to use Putty to finish this off from a remote session, since there's going to be some cutting and pasting involved. Alright, so we're back over here at the desktop again, logged into the Raspberry Pi, and the web page for setting up the Google Assistant SDK. The next step is to set the activity and authorization levels inside of the Google account we're going to use with this particular device. It's a simple link here to click on from the instructions. I will leave the link with all the other links down in the description below. So we need to set the activity controls. I am logged into the Google account that I intend to use with this. It doesn't have to be the same as your developer account. It can be any of the Google accounts that are available to you. One of the things we want to make sure, web and app activity is enabled. When I first got here, a lot of these were turned off. Location history, the Google Assistant needs to know where it is for some reason. Device information is important for the Google Assistant SDK, so it knows what it's running on and it knows what resources it has available to it. This one was also turned off for me. And obviously, voice and audio activity. If it can't access the microphone or deal with the audio on your device, then obviously this is not going to work. Those are the four that you have to turn on. My account has multiple others that are on too, so we're just going to leave those on. And once you've turned all of that on, we can go back to the web page that we were getting the instructions for setting the SDK up with. Okay, so now that we've set up the activity controls for the account that we're going to use with this, it's time to go ahead and authorize this particular client. So what we're going to do is we're going to pull up the Putty window, and we're going to type Python -m Google samples assistant auth _ helpers. Client secrets. And point to that JSON file that we sent to the Pi before. That should be client-secret. says credentials saved, so that means that is now authorized. Excellent. Okay. So now we should be able to go to the device itself. Okay, so now that we have everything set up and everything authorized to work together, I have done a test to make sure that this works so I don't embarrass myself. But we can go ahead and run the actual Google Assistant sample. And eventually we'll ask us to press enter in order to send a new request to Google. So let's try something. What is the weather like outside?
In Kitchener, it's 8 degrees with rain. It'll be rainy today, with a forecasted high of 8 and a low of 4. There is currently a rainfall warning in effect.
What is the weather like in Curtis?
Right now in Curtis, it's 9 degrees and mostly sunny. Today, it'll be partly cloudy, with the forecasted high of 11 and a low of 2.
Alright, so today we were investigating whether the Google Assistant SDK will work on a Raspberry Pi 2 and looking at how to install it and get started with the samples. We set up the hardware, we took a base Raspbian OS, we installed the dependencies for Python and the dependencies for the Google Assistant. We set up our Google account in order to be able to use the activities. We created an auth.json file and we added that to the Raspberry Pi and we authorized our Raspberry Pi to speak on behalf of our account. We then went ahead and tried the samples out and verified that we can get audio and that we can get audio back and that it appears to be working fine on a Raspberry Pi 2. So contrary to what has been published, where Google is very explicit that it's the Raspberry Pi 3 integration, definitely a Raspberry Pi 2 Model B can run the Google Assistant, which is great, so I don't have to wait for 3 to arrive in the mail. Stay tuned for more videos regarding this SDK. I'm going to be using it a lot in a few projects that are coming up. I hope you learned something today. If you did, give me a thumbs up. If you didn't, give me a sarcastic thumbs up. Don't forget to subscribe, and beside the subscribe button, you'll find a little bell icon. That little bell icon will ensure you get notified of every video that I post. Once again, thank you for joining me in the lab.